Algebra 2, target 35. I can use data from a sample to draw conclusions about a population. Focuses on confidence intervals. All right, we got two different ways we do confidence intervals. One way is from a survey with a proportion. All right, here's our formula. We talked about it in class. P hat represents the proportion of the sample that has the desired trait, and N represents the sample size. Then P is what we're going to be solving for. So the formula is P hat minus 2 times the square root of P hat times 1 minus P hat over N. That is really the standard deviation multiplied by the error, is less than our proportion, which is less than the same thing with a plus instead of a minus. So let's take a look. 300 people were surveyed about the new mascot for the local rugby team. The leading choice was the banana slugs, chosen by 34% of those surveyed. What is the confidence interval? Right, so our formula, P hat minus 2 times the square root of P hat times 1 minus P hat over the number surveyed is less than P, which is less than P hat, plus 2 times the square root of P hat times 1 minus P hat all over the number surveyed. Let's plug those numbers in. The proportion who wanted banana slugs was 34%, so that's 0.34. Minus 2 times the square root of 0.34. And then 1 minus 0.34, that's 0.66. All over 300 people were surveyed. It's less than P is less than the same thing, except plus 2 times the square root of 0.34 times 0.66. All over 300. All right, so we'll calculate that. We'll do 1 minus 2 times the square root, 0.34 times 0.66 divided by 300. Our lower level, oops, that's not right. It should be 0.34, not 1. So 0.34 minus gives us a lower level of 28.5%. Our upper level is the same thing. We're just change our minus to a plus. And our confidence interval is 39.4. So we are 95% sure that the average people that want the banana slug is between 28.5% and 39.4%. If we take a look at this and we compare this to when we're doing average, very similar. We pull out, we do our standard deviation instead of P hat times 1 minus P hat. The square root of N is still on the bottom. The reason the top's not in the square root is because that's part of the equation. So it's the same equation, just it looks different because of the situation. So we got the average of the sample minus 2 times the standard deviation times the error. It says divided by 1, divided by square root of N, but the error is 1 divided by square root of N, so it is correct to say times the error. So we'll take a look at this. Average income in Midwestern America is $58,233 with a standard deviation of $9,051. Calculate the confidence interval for a sample of 10,000 people. All right, so we're starting with the average minus 2 times the standard deviation times the error is less than X, which is less than the average plus 2 times the standard deviation times the error. If we plug in those values, our average is 58,233 minus 2 times 9,051 divided by the square root of 10,000. It's 100 for those of you that can do that real quick. Is less than the same thing plus 2 times the standard deviation times the error. All right, we'll plug those in. 58,233 minus 2 times the standard deviation of 9,051 divided by the square root of the sample size. So there's our lower bound. Go up. We'll get our upper bound by changing this to plus. So we are 95% certain that given a sample of 10,000 people, the average income will be between $58,051 and $58,414.